this are bandwidth intensive. So if you have other browser tabs, kindly minimize or close this in order to help you with some bandwidth or prevent any connection. The internet is also recommended technical issues. If you are not seeing the slides advance, pressing F5 command or press in command R. We have a new way of you getting them by logging in to learn that any of your Bentley profile. Just go to the ims.bentley.com and account. Now, if let's say you fail to create your account, you can also get them through your email. Okay, and if so happen you're watching this with your other colleagues, you can also fill in the group form so that they can also, or each of you can get your own certificates. Now, again, welcome to Accelerate Civil Conference. And we have been, or we have started this since July, last week of July, and we are on our 4th week this time. And we have gone through several topics already, okay? And for this week, I will be your speaker as well. So I am Maylen E. Cabalan, and I'll be discussing civil design modeling strategies using Open Roads Designer. And before I start, I would like to invite you all as well to the remaining sessions that we have up until first week of September. And I'm projecting the link from where you can also register in case you haven't registered yet. So let's start. Again, I'm Maylen E. Cabalan, User Success Manager for Civil Design in Southeast Asia, currently based here in Singapore. We are now on the 5th or 4th week of our Accelerate Civil Conference for Southeast Asia, Japan, Hong Kong, and South Korea. Now, I will be discussing more on the civil design modeling strategies using Open Roads or ORD. The main objective of this session is to provide some guidance and tips on how you can create accurate and optimized roadway model using open roads, but actually it's also applicable if you happen to I do hope you have also attended the other sessions which discuss these other, then an on-demand version is also available. Now, this is our agenda for today. And then why is it important that you do file federation or separation of your files? And then if you might have already encountered using corridor feature definition. So we will an accurate, okay, or an optimized corridor model. Then some corridor editing tools that will allow you to make sure that your corridor processing, okay, or your up interval, then key stations, then how do you do corridor clipping as important is geometry, horizontal as well as your vertical profiles or alignments, and then what is this thing called secondary alignment. To start, okay, good practice when you start a project to consider or determine outlined here 4 modeling strategies, which we'll go through one by one. So like for instance, when you're creating a corridor, would you want to use only one template for that entire corridor? When I say template, okay, for the benefit of everyone, or probably some of you who have not used Open Roads Designer, so template is a typical cross section, okay, that is extruded, okay, along the horizontal as well as the vertical direction of your geometry. So this will now become your 3D corridor model of the road, okay? So in a traditional workflow, usually you only use one full template, and then you just use some of the corridor editing tools so that it will transition or probably become or transition from one lane to 2 lanes or vice versa, or maybe target other elements, maybe your existing terrain or other corridors as well. Now, there's also an alternate workflow for this, which is using separate templates, thereby creating separate corridors. So you only have like a backbone template for your main corridor, probably maybe your 1 lane or 2 lane of a road. And then you also have another corridor wherein you use an end condition, right? And then probably a median and so on, okay? Now, regardless of which workflow you're using, the traditional and the alternate, now you have to also make sure that you consider the length, the width, as well as the file size of your project, okay? So the length of your corridor, in terms of the length of your corridor, you might want to create or use different drop intervals, okay? And for every drop intervals, you have different templates as well, and probably other this could cause, okay, either a fast or maybe a slow processing of your corridor. Now think about the length of your roadway project. Does it need to be subdivided into smaller length, okay? Or probably if you're using the alternate workflow I've discussed, would it be okay already if you use different templates, but then for the entire corridor, okay? So these are all based on you as a user or your engineering judgment. Your corridor would be already slow, okay? Depending on how modeling strategy that we will discuss later on is using, so when we say simple, it's just one main lane probably, then a gutter, okay, and then an end condition that will target the existing ground. Or maybe, okay, if we say complex template, you have display rules, okay? When it sees another geometry or it sees a different target, then the component dynamically changes. So we'll explore more on this later on. So let's start with the first strategy, using a full width template and corridor, or arriving at one corridor. So this is basically one template, one corridor, and then with multiple template drops. Another flow, okay, you have separate templates and separate corridor. Maybe you model the pavement first with this kind of template that you see on screen and come up with your corridor. Then you have your end condition, okay, which is actually can be considered as one corridor as well, which will do the cut and fill or yan, okay, or another end condition. So all of these can be a separate corridor. Okay? The advantage of this is that multiple people or modeling tasks, okay, unlike having one person to do all the modeling. Okay, this will be a good on a complex type of that will not disrupt the entire process. Okay, so if you're used to template for the entire corridor, okay, you will happen on the lane. Okay, so with having separate templates, okay, it allows you to simplify, okay, and focus on a simplified template. Okay, and distribution of work between multiple designers are very much supported. It reduces the time for a finished model to be created because basically simultaneous designer are working on the entire length of the corridor. And more corridors to manage. Okay, yeah, there are more corridors to manage, but the processing speed will be much quicker in most cases. Now, why do you need to split the corridors? One important thing to consider why we recommend this is because of the file size. It limits your file size, okay, into probably the recommended for us is, or when you're using the software, is 10 MB or less, okay, but it could also be larger depending on your project. But splitting your corridors keeps the processing time faster, okay, and regardless of the complexity of your corridor or length, okay, the processing will be optimized. And also with different or split up corridors, okay, you mitigate the problem easily, okay, if there are corruption in the references or in your XREFs. So it's easier now to track, okay, where is the broken reference or where is the problematic file, basically because the references, okay, are in different files, okay, and then on specific corridor, okay, sometimes you just need to focus on probably your right-of-ways or maybe end conditions. So it's easier to adapt, okay, to such kind of scenarios if you have if you split your corridor. And it's also easier for you to utilize template drops, okay, interval, and especially for those areas wherein you need to show a higher level of detail. Now, the third modeling strategy is with regards to the corridor length, the width, and again, going back to file size. Okay? Corridor length, width, and file size all play a role in the corridor processing. So choose an appropriate length for your project. So in this example here, you see on the left a 2-kilometer example of a road project. Full width template corridor may be okay to use since it only entails maybe few template drops, okay, at the beginning and maybe in the middle where the interchange is present, and then at the end. Now, for a 5 kilometer or more, okay, corridors, like you see here on your right side of your screen, maybe there would be ramps, interchanges, multiple lanes, okay, that would probably transition to smaller or two or one lane even, okay. This may pose processing or handling issues. So in this case, it would be better if we handle it with different corridors with each or with its own template and corresponding template drops. Stressing on the corridor length, width, and file size again, what we are looking is a sample cross-section of a complex road model, which as you can see here is a bit wide, okay? This is a very good example where corridor processing can be too immense, okay? Especially if your modeling techniques are not that good, okay? So with this kind of corridor model, it would be easier if you create or use multiple corridors to treat such scenario. Maybe the left side wherein probably it's gonna exit through the ramp, okay, will be one corridor, okay, and then it just meets another corridor in the middle, okay, and then of course another lane which probably is on the opposite direction. So it's separating these kinds of corridors, okay, will definitely be a better solution. Another modeling strategy, okay, that I would like to discuss is whether you use a simple versus a complex template. When we say simple template, okay, so meaning one template only from the start to end, okay, and there's no complicated display rule, okay. It's actually easier to debug, okay, meaning it's easier to see which has a problem, okay, in terms of you debugging them, okay. And although there's not much engineering automation that will happen because you're limited to just looking at the constraints that is present in the template, okay, and this kind of scenario usually requires more template drops to manage, which can be a huge factor in terms of the processing of your corridor. Now, a complex template, on the other hand, okay, could be difficult to debug and may cause slow processing. But then, the positive side is it automates your engineering problem, okay. When you say it automates, because if you are the one, or more or less this kind of complex template entails maybe an advanced user, okay, to understand, or an advanced open roads user to basically understand. But once this is properly set up, you would notice, okay, that you now need to create less, also easier for you to debug, okay, or probably know where are the problematic areas of your corridor. Okay, I'll just show you a video of a sample of a complex template. Now, as you can see here, this is an example of a complex template used in a road project. It looks like a median as of now, but there are actually some display rules embedded in the template depending on the existing design scenarios, or maybe the point controls or edits that the user expects as the road model is being designed. It will all depend on how you as a user understands the principle behind the template constraints or rules. Okay, this is a good example of how a complex template can basically help you automate your road design. But of course, you can stick with using simple templates and still manage to achieve the same results. And in a way, okay, this makes corridor modeling using open roads really flexible. Now, let's move on to some other tips on how you can optimize the use designer in terms of modeling your road. For the benefit of those of you who have yet to use the Connect version of our civil softwares, do note that with Open Roads Designer, all civil data is stored in the DGN file. So everything is in the DGN. The only exception to this is the template library, which is in the .itl file. So all your survey, terrain, geometry, it will all reside in its corresponding DGN. And for those who have probably used our other or old versions of our civil softwares like MX Road or InRoads, if you can recall, the geometry files or terrain files are all in different file format. Okay, especially the geometry. The geometry itself, as well as the geometry tools, no longer exist, thus creating and managing geometric alignments requires a new workflow and a different way of thinking. So the software is designed to work with reference files. So it is necessary to establish how you are going to work with all of those reference files on your project. It is essential that you federate and separate your project files as well as establish a logical folder structure and file naming. Now, to better understand that, okay, this would mean that probably your survey or topo data would be in one DGN. Same with terrain in one DGN, geometry in another DGN, corridors in another DGN, and so on. Okay? It could also be probably based on discipline. Okay? Like for instance, all your plan, profile, or probably your cross-section sheets are in one DGN. Okay? That references the other DGNs that I have mentioned. Your drainage, you have one master model saved in a DGN, okay, and then referencing all, again, the other DGNs that I have mentioned, and bridges, geotech, okay, and so on. Okay, you typically want to separate your files probably based on discipline or based on design function, like what is shown here in this slide. Now, why do you need that? Okay, actually, I've mentioned some of it already earlier. The main thing, okay, main reason is because smaller files are faster and more efficient to handle. It's easier to manage and recall where things are if you separate your objects or your civil objects. Multi-user access is also possible, especially if, let's say, you are 2, 3, or more in a team of designers, right, or modelers. So more people can work on individual tasks. And another positive reason is you can control later, okay, or you have more control, okay, later when you need to compile the files for different scenarios. And another thing is when you debug the files and investigate as to which one has a problem in your project, it's actually easier if you're using file federation or separation. Now, it is actually important to establish a logical folder structure from the very start of your project. So an effective folder structure can be based on discipline and maybe based on civil data as well. When I say civil data, terrain, geometry, or corridor, like what you see here in this example. Since all open roads files share a common .dgn extension or file extension, it's important to establish a clear and logical file naming system. Now, the file naming system could be based on what is or what you're using as a convention, or maybe based on the project mandated by the owner. Okay. Note that in this example, like for instance for geometry, we have the project name listed first, then the design function, so in this case a geometry, and then the name of that geometry. So like you're seeing here, geometry folder, and then we have the project name SR97 underscore geom, then each of those probably road names. Now for the corridors, it's the same. So project name, civil data type, name of the civil data type. So like in this example, SR97 is the project name, corridor is the civil data type, then route 97 is the corridor name, and so on. Now this is just this is just an example, okay? So it could also be based on the logical folder structure that you actually already implement in your organization. Now, how should we separate your civil objects? Like for instance, your alignments, your corridors, and super elevation. So we would recommend that you separate this file, okay? Probably the most common workflow that you're doing is you create alignment, and then you apply super elevation, and then on the same file you generate your corridor. Okay, so to optimize or to make sure that you won't have any processing problem later on, okay, in terms of the file size and the corridor processing per se, again, we would recommend that each alignment should have its own file, super elevation section should have their own file, okay, and corridor would only reference this alignment as well as super elevation, and then create, or you have your own corridor file that references all this. So remember, we can always reference all of this information together at any time through the use of the container file or master model, which we will also you will also see in the later on presentation. Now, another thing to take note is when you're already in the modeling of the corridor, okay, there's this property called feature definition, which is actually also applied to your geometry, to your terrain, to your super elevation sections, okay, which is actually common for all open roads objects, okay. Now for corridor, we also have such, and it actually controls the display as well as the accuracy of your corridor model. So like for instance, in this slide here that you're seeing, the corridor feature definition is set to final, okay? Then it could be also set to maybe showing preliminary design only or conceptual, okay? So based on this feature definition, there are other settings that works on the background. Like for instance, processing, or how is the processing of the stations or the templates along the entire corridor. So it's very important to take note of the level of detail that you want to show in your corridor so that your processing speed, okay, would would be optimized or much faster. Okay. And then also we have this display settings, like for instance, if you need to turn on the top mesh or the bottom mesh of your finished corridor. Okay. So if it's not yet important for you to show them, maybe disable them by digging to the display settings and setting them to false. Okay. Another factor that would affect the processing are your manipulator settings. Manipulator meaning those handles or grips that you see on the plan view or probably in your cross-section view as well as in your 3D model in order for you to modify the corridor. So these things also affects how the corridors are being processed. Now, two of the most important sections of corridor feature definitions are processing and critical sections and display settings. They will basically define the level of details that you want to show. And some of this can be a factor in the processing of your corridor in your design. And a better way to make sure, okay, that you know what's happening when the corridor is being processed is you have to make sure you're aware of the settings. Now, if in case that you are unsure and you don't have time to really dig onto this in a much deeper manner, then probably just use default settings. Now, let's clearly understand this corridor feature definition. As you can see here, okay, in your screen, there is a ramp portion of a highway project which is actually set to have design or final feature definition. So currently, okay, the design feature definition is being selected and its properties are shown on the left side, which is the properties window. So if you notice here, okay, the processing of critical sections are based on the num that will be processed in the corridor. Okay. And currently it is set to a factor of 2, okay, which just means that if your template drop is every 5 meters, then times 2, it will create the template drop every 10 meters. So this would mean this would mean faster processing because you have less computing, okay, at the background. And then with all the other settings, like for instance, the cardinal points that needs to be shown as well. Would there be a template drop for each horizontal or maybe vertical cardinal points? Is that necessary? And when I say cardinal points, these are maybe your PC, your P alignment, or your VPC or BPT in your vertical alignment. And also, if you have some curved areas, how would the corridor model be processed? Okay, will be dependent on the settings that you will choose here. Okay, then looking at another option or another feature definition, which is now the final, okay, feature definition, and comparing this to the previous one, notice how the number of lines, okay, perpendicular to the corridor has increased. This is basically because if you notice at the template drop processing multiplier, it now has changed to 1. So meaning to say, if your interval is every 5 meters, it would stay 5 meters all throughout. Okay? So, meaning more processing at the background. And thereby, okay, making the process or computing of the corridor a bit slower. Okay? So these are the things that you have to consider when you're setting of your corridor. So you have to make sure that you understand all these settings before you create your corridor model. So another thing that we need to consider, so I think you've been hearing me discuss about or mentioning about template drop interval, okay? So we need to make sure that we assign a good interval, okay? Because basically, the corridor processing will depend on that value. Okay, so like if you would apply the template every 5 meters, every 10 meters, or every 25 meters, that would be a factor in terms of the processing later on. Now, there's no right or wrong value, okay, for your template drop. Okay, it all depends on the level of detail that you want your model to have. You may need to use smaller or tighter template drop interval if your corridor needs to process some transitions. So it will all really depend on your strategy. The next thing I want to discuss is regarding key stations. So key stations are more like one of the, or is one of the most underrated tool amongst the corridor edit tools in open roads. It is often overlooked and not used, okay, but it is actually a useful tool which adds additional template processing stations and can achieve to fill in the gaps of those areas that the corridor template drop cannot further process. So how is this used? So looking at this video here, so notice the main corridor on your left side of the screen has already been processed. Now it is being attached to a junction here, okay, which if you notice, there's this small gap on the lower portion of the 3D model, as well as a small portion there on the upper right corner of the 3D model, which is also visible on the 2D view. That the template drop could no longer be processed in this area. Okay, so by using or adding in a key station, the software will then process, okay, and fill in the gaps between that two corridors, okay, the main one as well as the junction. And then as soon as you have identified a specific station where the processing will be done, then the gap will then be filled in. Similarly, to the other side, the same process, just identify as to which station will it be applied, okay? And then start and end, okay, of this chainage or the station, okay, and then reprocess and then fill in the gap. Okay, so this is one of those tools that is very useful, okay, when you are already in the editing, okay, part of your corridor creation. On to how you can further make your model knowing how to use the corridor. So these tools are basically utilized to remove those overlapping portions, two overlapping slopes. Okay, now this video. I have a corridor. There is an overlap, the cut or fill on the return part. Okay, so what we will do is to use corridor clipping. We remove this overlapping slope. The add corridor clipping reference is meaning the corridor that you want to trim, and then the reference corridor from where it would be clipped. So as soon as you have identified this, the software now will update the corridor and clean it up. As quick as that. Now another example, target aliasing, okay, that works alongside corridor clipping. Okay, as you can see here in the slide, we have an almost finished corridor, okay, but on the portion where the main road is and the ramp, okay, there is an overlapping slope that you can see in the cross section, okay, because basically the default setting is that it targets the existing ground, okay, but then we have to clip with respect to this two corridors, okay, along this long roadway. So how do we do that? So as you can see here, okay, there is an overlap. Then we first use the target or define target aliasing. So the first corridor that we will clip is the ramp area. So we clip that with respect to the main road, okay? But then how do we clip or how do we remove the overlap of the slope in the main corridor? So what we will do here, since we are using a federated way of handling our files, we open the main corridor, okay? And then in the main corridor, we reference that ramp that was already clipped, okay? And what we will now do is to, since now you're seeing the ramp alongside the main road, okay? What we will now do is clip this with respect to the ramp that we have attached, okay? So same process. Although you're not seeing the result because we are not seeing the cross section, but we will now go back, okay? We will now go back to that master corridor file. And then look at the cross section to see if the target as well as the clipping has been applied. So as you can see now in view number 7 that it was, it was indeed clipped. Okay, both corridor slopes were clipped. Now another example, okay, from where you can minimize or optimize the processing of your corridor is by using linear templates or maybe surface templates. Okay, a good example is when you're modeling maybe medians or island or median island example. So in this example here, I would like to show how corridor clipping can also be used for creating median island, and maybe in an urban type of road that you're seeing here in the slide, this can be very useful when you're modeling. So let's see this in action. So we have the main corridor in the upper right view, showing an almost finished corridor. But the scenario here is that we want to add a median island, which will also probably act as a turn lane. And on the left view, we have a 2D geometry, which has no elevation yet. So since our corridor already has an elevation information, we will use that as the reference, okay, elevation for our 2D geometry. Okay, so let's first display the profile of this geometry that represents the median island later on. And then what we will do is assign an elevation to it, okay, by using a tool and extracting the elevation based on the corridor. So that's the cyan color now that you're seeing. And if we activate that, you will see that particular line being shown on top of the corridor itself. And with corridor clipping, okay, we will more or less like punch a hole, okay, in the middle of this corridor, but following, okay, horizontally as well as vertically the geometry that we have projected onto the corridor. There you go. Now, for us to start modeling the median or the island median, okay, we will now use some model detailing tools like the linear template, okay, probably your curve, okay, that will run along the geometry that you have created. Choosing a template from your template library, okay, and of course you should be having or have created this prior to this process that I am showing. Okay, so once you have that placed, okay, the process is basically the same as corridor modeling. Okay, it's just that it's using a simple curve component, okay, and linearly following the direction of that particular geometry. Zooming in, you now can see the curve. So the next part is how do we further cover the punch or the whole area. In this case now, we will create first a terrain from the geometries generated by the curve. Okay, and we will now use some terrain tools or terrain modeling tools to be able to generate that. Okay, so we'll extract it based on probably the curved top of the curved template, and then generate the terrain, as you can see here. Now that terrain, okay, is just one mesh, and if you need to apply some materials to it, this is now where you apply a surface template to it, so that you can model, okay, or more or less model or represent the pavement, okay, of the median island itself. So again, prior to this process, you should have created this surface template beforehand, and then apply it in the corridor or in the terrain. Okay, so looking at this, we're done with our corridor, and then It's a good technique, okay, in terms of modeling, okay, this type of road scenario, because it makes sure that you optimize the corridor tools or some corridor modeling tools in order for you to make sure that you have a good corridor model. Okay. Now, another item, okay, the second to the last item that I would like to discuss is about geometry stroking. So every time you're creating 2D geometries and 3D geometries, okay, the number of the vertices matters, especially if you're gonna use this to generate terrain or maybe your corridor, okay, especially your corridor. So this is actually what we call geometry stroking. So we have three types of geometry stroking. So curve stroking, if there are curve in your geometries. Linear, if there are straight, right? And then, of course, your profile, to make sure your elevation, vertice, or your vertical geometries also follows or has a good number of vertices, so that when you're processing it to become a corridor, it would be easier. Okay. Now, to visualize this, because I might not be making sense, this is too technical. It's too technical. So let's take a look at this example. Okay. So what I corridor model of a curve return. So basically, from a linear template applied along a curve geometry. Then a terrain model also is generated from all the geometries meant for the edges of pavements and center line of the road. Looking at the properties of this geometry here, okay, so when we say the geometry, that's the curve return part, okay, of the road. So looking at the properties, we see that the curve and the profile stroking a certain value. Okay, so see there, the curve, stroking, profile. Okay, if we change this to become maybe higher value, right? So currently it's 0.07. If we change this to 1, and then the linear stroke value of 20 or 25, okay? And as it generates the corridor, notice now that it affected how the corridor is being processed. The curve now isn't that smooth anymore as compared to earlier, which is basically resulted into an inaccurate model. So this actually affects how your corridor, or not only your corridor, but also your terrain. So notice now that if I change the stroking back, okay, to the smaller number as it was before, or even smaller, then the curve now becomes smoother. The line now as well becomes smoother, affecting the corridor, affecting the terrain. So this is how important geometry stroking is. So if it's not really that important to have a very low geometry stroking, then don't set it to such value, because it will actually affect the processing. Okay. So one last tip that we will discuss is what we call secondary alignment. Okay, what is this? This tool is basically used to change the direction on how your template is being processed along the corridor. This can be a standalone tool, or it also works with point control modeling tool. Now, let's look at that, or let's see that function using this video here. So in this example here, that probably represent maybe the widening or maybe a bus bay, okay, depends, okay. Notice how the template drop are processed perpendicular to the main alignment, which is the red line in the middle of the corridor, which is basically the default, okay. This is the default processing condition. But what we want now to happen is to have the template be processed, okay, especially in the taper part, perpendicularly to the taper alignment. Or this taper alignment could be edge of pavement. So to accomplish this, we will now use the secondary alignment tool. So as you can see here, I'm identifying the corridor, then the linear element where the secondary alignment will be applied. And then as soon as it's done, look at the 3D model, especially the green cut or fill on the left side of the corridor model. So notice now that the template has been processed perpendicularly to the taper geometry and not anymore with respect to the red line that you're seeing in the 3D. So this is one example. How about if, let's say, for instance, you're using the point control tool and then you also want to do widening, okay, of your road, and then you want to make sure that your geometry is considered as secondary alignment as well. So what we want to do here now is to widen our corridor based on this linear element that you see on the 2D view on the left, which represents the new direction of our edge of pavement. In 3D, you are not yet seeing it at this point, okay? But the main corridor without the end condition is already processed, which you see on the right. So using the control point tool, let's use this geometry as the linear point control, which will be followed by our template horizontally, okay, from a specific station start or station range. Now notice the option use as secondary alignment. We tick on that, okay, we make sure we tick on that so that the processing of the template will now be perpendicular to our widening that we want to process. So once this is done, okay, let me just okay, so once this is done, notice now the templates are processed perpendicular to the taper, similar to the previous process, but basically dependent on the point control command. Okay, so this is again a good tool for you to be able to make sure that you're really optimizing the editing of your corridor. Now, in summary, okay, I'm now down to my last slide, okay, just to summarize everything, okay. Again, the main objective of this presentation is really to help you optimize how you design your corridors using open roads as well as open rail, okay. So we've given you, or I've given you, some modeling strategies in terms of your templates, template drops, okay, and also how you do file federation, some recommended tips, and then how important corridor feature definitions are, and then if there's a need for you to make sure that your drop or template drop interval is set properly, and then the tools for corridor modeling like key station, corridor clipping, target aliasing, and then some of those settings that you might not be aware of, like geometry, stroking, and then secondary alignment. Okay. So with this, I'm ending my presentation now, and I do hope that you took away, or you have a great takeaway as to the topic or the content of the presentation. Now, before we finish the session, I would like to encourage you to type in your questions. Okay, if you need to clarify or address some points that you want to be addressed by me. Okay, kindly just type it in the Q&A widget or chat box. And also, if I may ask everyone, kindly fill in or take your answer in the poll question that I have projected on the screen. Okay. Now let me go through the question here. We have a friend here, Alexander, asking if he can have a copy of the slides. Okay. There will be an on-demand version of this presentation. Okay, you can go through watching it again, or you can also probably email me directly so that I can give you a PDF copy of the presentation. Okay, so I'm sending my email to you, Alexander. Okay. So if you guys have other questions, please feel free to type it in. Okay, and also don't forget to just click on the poll question that I have projected on the screen. And then while I wait, if there are still some questions, I'm again inviting everyone. I'm inviting everyone to still register to the remaining 3-week session of our civil session. Okay, and I've already projected on the screen the link, so you may want to register in the other session. And for those who have missed out the other session, you can also use the same link to register to the on-demand versions of those sessions that you have missed. Okay, so since there are no other questions, I think we just end the webcast or webinar now. And thank you again for your time. And I do hope to see you again on the remaining sessions. We have a session on Friday, 11 a.m. and again 1:30, and then the succeeding weeks, Tuesdays and Fridays up until first week of September. Okay. Thank you guys, and have a great week ahead, and thank you.